A square loop ABCD. This is the loop ABCD, carrying a current I. Whatever the current it is flow here, that is I, is placed near a coplanar with a long straight conductor. This is the conductor, coplanar conductor XY, carrying a current I. This is the XY coplanar conductor carrying the current I. Then the net force on the loop will be, what is the net force on the loop? We need to find here. Fine. Then we know that the force on the arm AB, the force on the arm AB on this arm due to the current in the conductor XY, due to this conductor is given by, that is F1. We can write this one as F1, that is equal to mu naught divided by 4 pi times 2 into I into I divided by L by 2, which is equal to mu naught divided by pi, and here I into I. So this is the force on the arm AB. And this force acts towards the wire. Whatever the force is there, this is act towards the wire here in the plane of the loop. And the force on the arm CD, on this force, this side, on this arm, whatever the force is exerted due to the current in the conductor XY is given by, we can write that one as F2, which is equal to mu naught divided by 4 pi times 2 into I into I divided by 3L by 2. Then which is given equal to mu naught into I into I divided by 3 pi. And this force is there, that force acts away from the wire. This force acts away from the wire in the plane of the loop. Then the net force on the loop is, that is we can write it as net force, that is F net. Net force is equal to F1 minus F2. Then we get here mu naught into I divided by pi times 1 minus 1 by 3. Then the final equation is 2 by 3 times mu naught into I whole divided by pi. This is the net force on the loop ABCD. Where this option is there, we need to find. That is 2 by 3 mu naught I into I divided by 3 pi. So option A is our right answer.